Okay, welcome to this supplementary example set. We're going to be working on some of the problems from your handout package. So two things that you need for reference right now. The first is the handout with all the example problems. Specifically, we'll be looking at day 6, example number 1 right now. The second thing that you'll want to have on hand would be the handout that has the 5 kinematic formula for accelerated motion. So if you have those two handy, we're going to look at this first example, which is looking at the magnitude of a bullet's acceleration as it travels, starting at 1200 meters per second and stopping inside a bulletproof vest. That's only 1 centimeter thick. So we're going to calculate the acceleration as it slows. So as with all these accelerated motion problems, the first thing we're going to do is list the givens. In this case, it's initially at V1, 1200 meters per second. We're given a V2 because it comes to a stop, so V2 equals 0, and it says 1 centimeter thick, so that would be the distance through which it stops. So delta D then would be 0.01 meters. I notice I did not even write 1 centimeter, it needs to be in meters, and that's important. Okay, and it's looking for acceleration. So the strategy to figure out which formula to use will be to look at your sheet and identify what you're not given, what piece of information we don't know anything about. And you'll notice we have not written time. There's no mention of time in the question, so you choose a formula in which there is no time. So as I go through the list of formulas, if you go to formula number 4, you'll notice that there is no time in that formula. So that's the formula we're going to choose, and we're looking for acceleration. The basic form of the equation is this. If you look on the form, it does give the accelerated, rearranged form, for acceleration, and I'll leave it to you to do that rearranging on your own, but v2 squared minus v1 squared over 2d equals a. Having that, you just solve in for the givens that we have. 0 minus 1200 squared over 0.01 equals 2. And it will be a very, very large number, which makes sense because it's slowing from a huge speed. Okay, so it's going to be 7.2. I'm going to put it in scientific notation. I'm sorry. Hard to put a check mark on that because that's a gigantic number, but it does make sense that it's big because it's going from a huge speed to a very small speed in a short time.